the CARAHCAST Data Center Innovation Series, where we dive into the trends and issues shaping the future of data centers in the public sector. I'm your host, CARAHCAST Consulting CTO Scott Robon. Today, we're going to focus on networking in the next-gen data center, and we're thrilled to have Greg Bensimon, a data center sales specialist from Juniper Networks, joining us to talk about what he's seeing across his engagements in the public sector and U.S. federal data centers. As we see the continued explosive growth of the data center industry across all sectors, we know that networking plays a key role in making data centers function. Well, Greg and I know this. Not everybody has the same appreciation that Greg and I do. Um, Compute has to connect to storage. Application components need to communicate across physical and virtual machines. And application architectures often span across wide area networks into multiple clouds and multiple data centers. Greg is going to help demystify some of this for us today. Greg, welcome. It's great to have you here. Can you give listeners a brief intro on how you got into the data center networking space?
Sure, Scott. Thank you. It's good to see you again, too.
Same.
That's been part of my natural evolution here at Juniper. I've done IT my entire career back from the days where we called it data communications. Most of that has been WAN, but over the course of the last 10, 15 years or so, particularly as the technologies we're using in the WAN started to make their way into the data center, it became sort of a natural evolution. So I've been supporting data center across federal, commercial enterprise, and even SP now for about 15 years.
I know you have lots to observe from this. Let's ease into it slowly, and we'll start out with some general trends.
Okay.
So from what you're seeing, what's happening from the evolution of speeds, feeds, and architectures. What are you seeing there?
Yeah. Well, things are always getting bigger and faster, and I think the data center environment tracks more closely against Moore's law than any other aspect of IT. The modern data centers is, in a lot of ways, a very large distributed computer. It's a design that allows us to place and scale compute and storage both quickly and flexibly, and to do so using relatively simple components.
Well, Jensen Huang has been out there saying, the data center is the new unit of compute, right?
Mhm.
So it's the new mainframe. Sorry, I don't want
Yeah.
to disrupt you.
No,
Yeah,
no, no.
yeah.
So
But yeah,
go ahead.
keep
I'm
going.
sorry.
Well, from an architecture perspective,
Mhm.
would you say things are getting simpler or more complex? What's that interplay between simplicity and architecture and scalability?
Mhm. Well, I think the reality has been that the networking has always been complex. It's just been a matter of what we've become accustomed to over time. So I don't know that now is particularly simpler or more complex than yesterday, but it is certainly complex in different ways. The good news, I think, is that the modern data center is more scalable and resilient than at any other time in our history. So whatever we think about the complexity, I think we have the opportunity to build something more robust than we ever could before.
Do you see real lessons learned from what the hyperscalers have done to drive scalability and resilience?
I do, absolutely. The most important thing that we can learn from the hyperscalers is that we want to build things out in a very repeatable way. We don't want one-offs. We
Yeah.
start from a set of very well-defined components, things that we can understand really well, both fundamentally and from a testing perspective. And then we reuse those things over and over and over again. I've had lots of folks tell me over the years how much they want to be like Google or they want to be like Amazon. A lot of folks tell me that from the standpoint of building their own automation. Uh, you probably don't have the software engineers that a Google or an Amazon has, so I'm not
Right.
sure how practical that is. But if you really want to follow that model, then think about how you can build in a way that is standardized and repeatable and testable.